Hey guys, welcome to second semester and the start of our rationals unit. We are going to start by talking about multiplying and dividing rational expressions. So the first thing we want to know is what's a rational expression? Basically, a rational expression is some sort of usually fraction made up of a numerator, which is a polynomial, and a denominator, which is also a polynomial. And these polynomials could be any degree. Here we have the degree of 2 and a degree of 1, but that's the big idea. A rational expression is a ratio of two polynomials, or a fraction made up of two polynomials. So we're going to start by talking about multiplying, dividing, and simplifying these rational expressions. So we're going to start with the simplifying example. So here we have 4x squared over 10x. One thing that we're going to want to take a look at for some of our future material is, can the rational expression that I have be simplified in any way? So when I go to simplify a rational expression, we would simplify the same way we would simplify a fraction. So for example, if I had 2 over 6, I know that the top, the numerator, 2, and 6, the bottom, the denominator, are both divisible by 2. I could think of this as 2 over 2 times 3, and I could reduce those common factors. 2 divided by 2 is essentially what I'm splitting this into. 2 divided by 2 is just 1. So I would have 1 over 3 as my simplified expression. So we treat these rational expressions exactly the same way. So as I look at my problem here, I've got 4x squared over 10x. 4 and 10 have a common factor of 2. So that means I can divide 2 out of each of them. 4 divided by 2 is 2. 10 divided by 2 would be 5. And then I can do the same thing with my x terms, x squared and x. X squared, we know, has a factor of x in it. X squared is x times x. So I can divide that factor of x out. Anytime I divide something out completely, it reduces to 1. It's not 0. It doesn't just disappear. It reduces to 1. And then our x squared here would reduce to x. So our simplified rational expression on top would be 2x, and on bottom would be 5 times 1, or 5. So same way that we reduce fractions, we can reduce our rational expressions. Now, remember, as we're reducing that, we reduce common factors between the top and bottom. If I have expressions like x squared plus 5 and x plus 2, I cannot reduce any x's because x squared and x are not factors here. They're part of larger expressions. Okay, and we'll see that more a little bit later on. So we're going to look at reducing today, and we're also going to look at multiplying and dividing these rational expressions. So when we multiply and divide rational expressions, or multiply and divide fractions, I should say, as you should have done in that warm-up practice set, I treat these the same way. So when I multiply fractions, I multiply the terms on top and the terms on bottom. I do the same thing for rational expressions. I'm going to multiply the terms on top and multiply the terms on bottom. We also want to reduce as much as we can. I'm going to encourage you to reduce at the beginning of your problem, just to make your end work a little bit simpler. Sometimes it's hard to see all the things to reduce, particularly in our larger problems, if I don't reduce at the beginning. So here I see I've got some x's on top and some x's on bottom. So I've got 3 x's on top. That means I can reduce 3 of them with that 1 on bottom. Okay, so 4 minus 3 would give me 1, so those are all gone. And then 10 and 5 I can reduce. 10 divided by 5 leaves me with 2. 5 divided by 5 leaves me with 1. Left now, I would have 2 times y, so that would be 4y. And on bottom, I would have 1 times x to the first, so that would be x to the first, or just x. So I multiplied and simplified. On the next page, moving on to page 5, we're going to take a look at a smaller example of dividing rational expressions. When we divide fractions, some of you learned to copy, change, flip, but we know that we multiply by the reciprocal when we divide fractions. So for example, if I have a fraction divided by another fraction, my first term stays the same instead of dividing, I multiply by the reciprocal, the flip of that second fraction. Copy, change, flip. Again, some of you learned. Copy that first term, change the sign, flip that second fraction. Okay, multiply by the reciprocal. And then once it's set up as multiplication, I multiply across the top and multiply across the bottom. So for my second example here, I've got 2x over 3 divided by 4x. So instead of saying divide by 4x, I'm going to write this as multiplied by a reciprocal of this second term. So 4x I could think of as 4x over 1. And now we're going to flip this. We're going to take the reciprocal. So that would be 1 over 4x. And now we can multiply these fractions just like we did before. Again, I'm going to start by reducing. So 2 and 4 can reduce. 4 divided by 2 is 2. 2 divided by 2 is 1. And then I also have a factor of x on the top and bottom. X divided by x would be 1. On top, I've got 1 times 1 times 1, which is just 1. And on bottom, I have 3 times 2 times 1. That would be 6. So my simplified answer here would be 1 over 6. Now, for each of the examples that we've looked at so far, we've looked at pretty simple little rational expressions that we were either multiplying or dividing. But we can have more complex rational expressions that we can simplify or multiply or divide. So that's what we're going to look at for the rest of our examples. So notice here, like I said at the beginning, since I've got y squared minus 81, and then on the bottom, 2 times y minus 18, I can't reduce these y's because they're not factors the way this is written right now, okay? I need to have factors in order to reduce, okay? So I could reduce 2 and x here because it was 2 times x. They were multiplied together, so they were factors. I could reduce 4 and x because it was 4 times x. They were multiplied together. They were factors. So if I want to be able to reduce anything happening in 1 through 6, I'm going to need to factor these, rewrite them in factored form. So if I take a look at number 1, on top, I've got y squared minus 81. I could rewrite that as y plus 9 and y minus 9. It's a difference of squares. So I can rewrite this in factored form, and now I could reduce an entire factor, not bits and pieces, but if I can reduce an entire factor, that's okay. On bottom, if I go to factor this, I have a GCF of 2, so I'm going to pull that out. That would leave me with y minus 9. So there's my factored form there. So now I want you to notice I have y minus 9 on top and y minus 9 as a factor on bottom. So I can reduce that entire factor. You can reduce factors, not individual pieces, if there's those plus and minus signs, okay? So reduce those factors. That would leave me with y plus 9 over 2. So there would be my simplified rational expression. Number 2, same idea. I'm going to factor each of these pieces. So I have a GCF I can pull out here. That would be x times x minus 2 for the top of my first fraction. On bottom, x squared plus 2x plus 1. That could factor into x plus 1 times x plus 1. And then we're multiplying by the second term here. I could factor into x plus 1 times x plus 3. And then my last term down here at the bottom, we have a GCF of x. I'm going to pull that out, and I get x times x plus 3. Now that I've factored, I can reduce any factors that are common to the top and bottom. So I see I've got a factor of x on top and bottom here. I can reduce that. I've got x plus 1 that I can reduce with one of these x plus 1s. And then x plus 3 I also have on top and bottom. Now left over, I have x minus 2 and x plus 1. Problems like this are why I want you to reduce before you multiply. If I were to distribute these things together, it would be very difficult for me to be able to then reduce it at the end of my problem. So I want to factor, reduce anything I can at the beginning, and then should have my simplified rational expression at the end. Number 3 is a little tricky. I can see I have 3's on top and on bottom that I will be able to reduce. And then my other terms, I've got 12 minus x and x minus 12. They look really, really similar, but they're not exactly the same. They're in the wrong order. So I'm going to be a little tricky here. I'm going to reorder this as negative x plus 12 to start. And then I want the signs to match so I can reduce these. So I'm going to pull out a GCF of negative 1. Being a little tricky here, that will change my signs to x, positive x minus 12. Now I can reduce this factor of x minus 12 and this factor of x minus 12. I can also reduce my 3's here. And I'm left with negative 1 on top, and then not 0 on the bottom. Remember, when I reduce things, I'm left with 1. So negative 1 over 1, or just plain old negative 1. Number 4 is similar to what we saw in those first few examples. Everything here is being multiplied together, right? On each of my numerator and denominators, I'm just multiplying a bunch of stuff together. I don't see any addition or subtraction signs, so I can do that sort of piece, the individual bit and piece reducing here, okay? But before I do that, since I'm dividing, I'm going to need to take the reciprocal of the second term. So I've got 12x squared y over 5y squared times, reciprocal here, would be 2xy over 3x squared. And again, since in each of these pieces I'm multiplying everything together, that means that I don't have to do any additional factoring like what we did in 1, 2, or 3. So if I take a look at what I've got here, I can see I've got x squared and x squared. So I'm going to go ahead and reduce those. I've also got 12 and 3. 3 is a factor of 12, right? 12 is 3 times 4. So I can reduce those 3's. I've also got some y's on the top and y's on the bottom. So I've got 2 y's on the top. Those will completely reduce my y squared, right? Because that's 2 y's on the bottom. And then let's see what I have left over. I've got a 4, 2x on top, and on bottom I just have 5. None of those things will reduce anymore. So 4 times 2 times x would be 8x over 5 on the bottom. There would be my reduced rational expression. A couple more examples to take a look at here. Number 5, x plus 7 divided by this rational expression. So I'm going to go ahead and factor these things and then write out the reciprocal version over here. X squared plus 9x plus 14 would be x plus 7 times x plus 2. And then x squared plus 5x plus 6, that would be x plus 2 times x plus 3. X plus 7 is as factored as it's going to get. So what I have here would be x plus 7 over 1. I like it to look like a fraction, times the reciprocal. So I've got to flip this. So this goes on the top, x plus 2 times x plus 3. And then on the bottom, x plus 7 times x plus 2. Then again, I'm going to reduce any factors that are common to the top and the bottom. So I've got x plus 7 and x plus 7 that I can reduce, and x plus 2 and x plus 2 that I can reduce. So I get x plus 3 over 1, or just plain old x plus 3. For our last example for today, I've actually got 3 different rational expressions that I'm multiplying together. I'm going to treat this the same way I treated every other problem, okay? Factor anything that I can, Since I'm dividing this middle term, I'll have to take the reciprocal there and then reduce anything that I can. So if I take a look here, I'm going to go ahead and write my factors for everything before I rewrite this with that reciprocal. X squared plus x minus 30 would be x plus 6 times x minus 5. X squared minus 2x minus 15 would be x plus 3 times x minus 5. X squared plus 7x plus 12 would be x plus 3 times x plus 4. And then x minus 5 is as factored as it's going to get, so is x plus 6. I'm going to rewrite this over here because, again, we have that division. We're going to have to flip this middle term. So I get x plus 6 times x minus 5. And I like it to look like a fraction, so I'm going to write that as over 1. And then I want to multiply by the reciprocal of this middle term. The middle term is the only thing I'm dividing by, so that's the only thing I need to flip. So this would be x plus 3 times x plus 4 on top. And then on bottom, x plus 3 times x minus 5. And then my last term, I'm multiplying by x minus 5 over x plus 6. Now I want to reduce any factors that are common to the top and bottom. So I've got x plus 6 on top and bottom that I can reduce. I've got x minus 5 on top and bottom that I can reduce. Over here, I've got another x minus 5. It doesn't matter which of them you reduce, but you can only reduce one from the top. And then we've got x plus 3 and x plus 3 that we can reduce. So left on top, I have x plus 4 times x minus 5. And on bottom, we just have 1. I'm going to go ahead and leave this in that factored form. That's fine. If your directions specify that you need to distribute, then remember we would be distributing, and you would get your distributed version would be x squared minus x minus 20. But in general, factored form is going to be fine. So that's multiplying, dividing, and simplifying rational expressions.